20 years ago, Brian Foote and Joseph Yoder coined the term "big ball of mud" to be a nice euphemism for a software disaster. A big ball of mud is a software system that grows badly and uncontrolled, and that is really hard to fix. Hidden dependencies make the system rather intricate, leading to duplicate portions of code and an unclear identification of layers. A big ball of mud doesn't get formed overnight, and it is also never that big in the beginning, and no individual developer can create it all alone. A big ball of mud is always the result of some teamwork. Overall, I see 4 factors leading to a big ball of mud: requirements and features, precision of estimates, requirement churn, and the overall role of management. Software is written against requirements, and the requirements must be deeply understood to identify the features to code. So stakeholders describe what they believe they want. In good faith, they may, however, omit or downgrade some critical details, or even describe business processes in a rather convoluted way. The information captured is reported to developers, and if not clarified along the way, it might generate the wrong code because developers build what they understand. And in full good faith, developers may happen to misrepresent the actual business. So both parties, when things go wrong, believe the wrong things, which basically means that communication has failed. As a manager, simply recommending you guys talk is neither enough nor effective. Let's talk about the precision of estimates now. There is a canonical pattern when it comes to this. Stakeholders love to have fixed costs, but they are only able to envision high-level features. For example, a stakeholder can request a login page, but a stakeholder can hardly distinguish between a plain username and password page and a more sophisticated page that uses social networks to authenticate users. On the other hand, developers need to know the nitty-gritty details of the process to implement in order to make an accurate quote of the effort. The combination of these 2 factors leads to the conclusion that no quote is ever accurate enough. I also love to say that quotes are subject to the butterfly effect, and I'll return on this in just a moment. So in the end, costs are relatively fixed, but fixed here means at least as high as the costs of the worst known worst case. In alternative to the canonical approach to making estimates, there is a new emerging trend called no estimates. The idea here isn't to eliminate estimates at all, but rather to focus more on the quickest way to get the software you need. Even the most accurate estimate you can get still doesn't solve any business problem. So the point becomes, you want to know how much it will cost, or you just want to have software ready. Keep in mind that any accurate estimate requires some big design effort up front and also frozen requirements. As you understand, both are quite impractical and expensive today. So what else? Just learn more about the no estimates approach. The butterfly effect here is an erudite citation from the chaos theory, which is also featured in a popular novel from Ray Bradbury, one of the fathers of the science fiction genre. In brief, the butterfly effect is when a small change in one state of a system results in much larger differences in a later state. In software terms, any new requirement that someone adds to an existing system, whether finished or in development, changes the context of the system and may trigger a different dynamic. In software, this phenomenon is also called requirements churn and can only be addressed through continuous refactoring. And now let's talk about management. Both managers and developers pursue legitimate objectives, but managers tend to be more aggressive than developers in pursuing their legitimate objectives. An ideal situation instead is when managers and developers stop fighting each other and find a common goal to share. Anyway, project management is not easy, and it gets even harder when a manager yields to the pressure of some false positives. For example, arbitrarily holding estimates and then complaining that the project is late, or perhaps hiring cheap developers and complaining the quality is low, or ignoring customer feedback and then complaining the product is badly received and poorly rated, not to mention the hardest of all false positives, adding manpower when the project is late. Adding manpower to a late project just makes it later. This is a piece of wisdom that is known to developers and managers since a very long time. This ends the first module of the course. The perverse mechanics of software design is when a project turns into a big ball of mud. In the next module, we'll look at the classic domain modeling as the new big upfront design anti-pattern.